We are continuing with the June 2023 GAUTENG exam paper, right? So, yeah, let's go. So, question 2, right? So, this is the sequence and series question. So, it says, in a geometric series, the sum of the first n terms is given by Sn, right? And it says, and the sum to infinity of the series is 10. So, first things first, right? We cannot view this as a sigma, right? What I mean by this is just the sigma is this one where they give you, let's say n is equals to 1, and then they give you infinity there, and then they just give you something there, right? Note, whatever we get here, right, is like the formula, right, to get the terms in sigma, right? But in this case, we were not given the formula to get the terms. Instead, we were given the sum formula, right? So we cannot replace n as 1 and then replace n as 2 and just simply get the terms like that, you understand? Because this is the sum formula. It's not sigma, right? But it's kind of the same thing. But okay, so this is how we do 2.1. They want us to calculate the values of k, right? So yeah, let's go into it, right? So we know that k is something there, right? It's just the coefficient of whatever is inside of the brackets, right? So okay, wants us to calculate the values of k. So let's view it like this, guys. So we know that k, right? K is part of the pattern, right? So whatever term that we replace, whatever we replace n with there, right, we're always going to get something with k, right? So let me just zoom in there, right? So if I replace n as 1, I'm going to get something with k, right? But now they've given us the formula, all right, of the sum of the series. So I understand that I can get the terms of the series using the sum formula, right? So let's try and do that. We know that the sum of the first term is equal to term 1, right? But the sum of the second term minus the sum of the first term is equal to term 2. So this is where it is, so it's equal to term 2, right? So let's just quickly prove that. Let's say we have a pattern here. Let's go. Let's say we have a pattern 3, 5, 7, 9, right? So we just want to prove that the sum, okay, let's just see the sum of the first term. We just said it's equal to term 1, right? And it is indeed 3, because 3 alone is just 3. But the term 2, right, the second term is equal to the sum of the second term, first two terms minus the first term. Look at this, because we understand that the second term, the sum of the first two terms is 3 plus 5, which is 8, minus the first term, which is 3 there, which indeed gives us the second term 5. Let's go again. We say term 3 is equals to the sum of the first 3 terms minus the sum of the first 2 terms. Let's prove that. So we know that the sum of the first 3 terms is going to be 3 plus 5, which is 8, plus 7, which is 15, all right? So 15 minus the sum of the first 2, which is 8, right? Which indeed does give us 7, which is our third term. So we're going to be using this analogy to waver us so we can just find a few terms, the first 2 terms, right? Because they've already told us that this is a geometric, right? So we can just use the first 2 terms that we find, right? So once we can get the first 2 terms, and then we just find our ratio. Because in most cases, when they are giving us sigma, for example, they don't tell you that it's a geometric or an arithmetic, right? So they just usually just give you a formula, and then you're gonna have to find the first 3 terms. But in this case, we just need 2 terms and find the ratio because they told us that it's geometric. So yeah, let's dive deeper, right? So let's find the first term, right? So we know that term 1 of this pattern is equal to the sum of the first term, right? But the sum of the first term is equal to S1, right? Let's do this. It equals to k into 1 minus 1 over 2 all to the power n, right? But we know that if we're looking for the sum of the first term, our n has to be replaced with 1 because that's the first term and it represents the position of the term, right? So in this case, we are going to get 1 minus half is 1 over 2. So we're going to get 1 over 2k. That's our first term, right? So that's our first term. We just need to get the second term and then find the ratio because we've been told that this is indeed an arithmetic, right? I mean a geometric series. So let's go. Term 2, like we've discussed, is equals to the sum of the first two terms minus the sum of the first. So we know that the sum of the first two terms, it's k into 1 minus 1 over 2, and the position is the second. So where n is, we replace with 2, right? And then we are going to get minus the sum of the first term, which you just found, 1 over 2k. 1 over 2k. Right? So yeah, look at this, guys, right? 1 over 2k there. So here we're going to have 1 minus 1 over 4. Right? 1 minus 1 over 4. That's going to give us 3 over 4k minus 1 over 2k, which gives us 1 over 4k. Right? So this is our second term, right? So we found the first term and we found the second term. This is term 2. And because they've told us that this is a geometric series, we understand that it has a common ratio, right? So now that we have our first term, our second term, we can find that common ratio. We know that the ratio is equals to what? The second term divided by term 1, or term 3 over term 2. But in this case, we just have these two terms, right? So let's dive deeper. So term 2, which is 1 over 4k, right, divided by what's the first term, which you got as 1 over 2k, right? So in this case, we're gonna have our ratio as 1 over 2, because the k's are gonna cancel out, right? So this is our r, right? So this is our ratio here, and then yeah, let's push. So now that we found our ratio, we can proceed to find the value of k, because they've given us another piece of information which says the sum to infinity of the series is 10, right? So we know that the sum to infinity, the formula is a over 1 minus r, given that r is less than 1 or greater than -1, right? But yeah, let's go. So they give us sum to infinity as 10, right, is equals to 1 over 2. Our first term is 1 over 2k, remember, right? And wow, right, 1 over 2k all over 1 minus our ratio, which we found as 1 over 2, right? So now let's just find the value of k, which is the only unknown in this case, right? So I'm going to do this. 10 is equals to 1 over 2k all over 1 over 2, because I understand that 1 minus half is still half, right? And then I just want to cross multiply. Take that there. Half times 10 is 5, is equals to what? 1 over 2k. All right? So I'm looking for k alone, so I'm going to divide both sides by 1 over 2. So k is therefore equal to 10. Right? So that's our value of k. Right? So just to rewind, in this case, right? So what we started with is understanding how we can use the sum, right, of a formula to get the specific terms that we're looking for. So in this case, we clarify that term 1, right, is equals to the sum of the first term, right? And term 2 is equals to the sum of the second term of the first two terms minus the sum of the first term, right? And then we proceeded to find our term 2. And now that we've been told that it's a geometric series, we understand that it has a common ratio, right? And then we just found the ratio as 1 over 2, right? So which clarifies our point now that we have our ratio, and they've also given us another piece of information telling us that the sum to infinity of this geometric series is 10. So we used that and found the value of k, right? So now that we found the value of k, let's go to the next question, right? The next question wants us to calculate the second term of the series, right? So now we have the value of k, and yeah, let's push, right? So second term of the series. So let's write. So we know that the second term, term 2, right, indeed is equal to the sum of the first two terms minus the sum of the first term. So the first sum of the first two terms, we did say it's k, right, into 1 minus 1 over 2 to the power of 2 there, right, because it's sum of the first two, that's our n, and then minus the sum of the first term, which is 1 over 2k, right? So now let's go. So in this case, we understand that now that our value of k is 10, we can just replace it there, right? So 10 into 1 minus 1 over 2 all squared minus 1 over 2 into 10, right? So that's what we have there. And then you're going to find that your answer is 5 over 2. So that's our second term. So yeah, this is question 2, right? Yeah. Hope you enjoyed. Please share, subscribe. We're on our way to 100 subscribers, and yeah, so let's just keep pushing. And yeah, if you have any questions, just please comment down below. And yeah.